Okay, for question 11, we have a ferulic acid. In this case, we are looking at three statements over here, which largely are reactions. So it's important for us to first identify the functional group present in ferulic acid. Now, ferulic acid has a phenol. You can clearly see you have a OH that's bonded to the benzene ring. This is a phenol functional group. The CC double bond over here, it's an alkene. And last but not least, we have COOH, which is a carboxylic acid. So if we now have identified the functional group, we can now look at the reactions. Can it decolorize aqueous bromine? Yes. Why? Because both the phenol and the alkene will react with aqueous bromine. Phenol will undergo electrophilic substitution. Alkene will undergo electrophilic addition reaction. So both of them will therefore use up the aqueous bromine and therefore decolorize aqueous bromine. Moving on next, in statement 2, it's not very soluble in water but dissolved in aqueous NaOH. So what can NaOH do? NaOH basically is a base. It can undergo neutralization. In this case, which are the functional group can undergo neutralization? Both with phenol as well as the carboxylic acid. And this results in forming your phenoxide ion O- as well as your carboxylate COO-. Now, once you form these ions, the type of interaction with aqueous medium will be your ion-dipole interaction. Alright, so this allows for ion-dipole interaction, and this will therefore allow it to be more soluble in an aqueous medium. And that's why, although it's not very soluble in water because you can only form hydrogen bond, but once it reacts with NaOH, it forms ionic compound, phenoxide, carboxylate, and as a result, it allows for the formation of stronger ion-dipole interactions with water molecule, and that's why it dissolves better in NaOH. Last but not least, it can be prepared from this using hot acidified dichromate. Now, can it be prepared using hot acidified dichromate? So if you take a look at it, what's the main difference in this molecule compared to ferulic acid is that you have a primary alcohol over here, CH2OH, primary alcohol. Now, when we use hot acidified dichromate, it's an oxidizing agent. It will oxidize primary alcohol to aldehyde and then to carboxylic acid. So yes, the CC double bond here will not be oxidized. It will not undergo oxidation because you're using dichromate, not KMnO4. The phenol pretty much remains intact because phenol can't undergo oxidation. So option 3 is therefore also possible. Alright, so this will then get oxidized to form your carboxylic acid. So therefore option 1, 2 and 3 are possible options. We are looking at option D. Alright, so I'll leave the answers here for a while. You can take down some pointers, but largely they have been explained earlier on. Okay, and that's it. We are done with this question.